All right, today we're talking about solving radical inequalities. This is part of our radical section. It's one of the best sections of the year because it's so rad. That was a bad joke. We're in period one. I think I saw one person smile. Today, what we're going to talk about is just solving a radical inequalities. You're also going to see how radical equalities sometimes will produce no solution. Some steps for those of you that like the step-by-step process. You do want to isolate the radical and square both sides. The big thing here is you also want to consider the domain of the radical inequality, and I'll show you how to find your answer when using a number line, because we still use the interval notation. And your answers must correspond with what you got solving and the domain as well. So let's take a look at this first problem here. This is a little more basic for what you're going to see. So x plus 7 is greater than or equal to 4. First thing that you're going to want to note is what the domain would be inside of the radical. You can't have a negative inside of a radical, but you can have 0. So you want to try and get as close to that as possible. A lot of times whenever you're dealing with anything underneath of a radical, let me get my marker there, you're going to take whatever's inside of that radical. Hopefully it lets me write. Let's see. There. All right. And then you're going to set it greater than or equal to 0. A little bit of technical difficulty here. So x plus 7 greater than or equal to 0. This will mean that x has to be greater than or equal to negative 7, which makes sense because if I plug negative 7 underneath that radical, I at least get 0. If I plugged in negative 8, which is less than that, I would get a negative number. If I plug in negative 6, I get a positive number that moves forward. That's going to help us whenever we go to set up our number line. So on the side here too, we're also going to set up just kind of like a nice little number line. And you'll want to note your domain within it, and then we'll also note our answer in it as well. Okay. I'll talk a little bit more about that here in a second. For now, let's go ahead and solve. So we've got the square root on both sides, so we'll want to square both sides. So x plus 7 is greater than or equal to 16, and x is greater than or equal to 9. On our number line, we want to place both of our results, our domain results and the actual result that we got whenever we were solving. So negative 7, closed circle, and everything's greater than. And then on down the line, you'll have 9. Again, closed circle, and everything that is greater than. Based on our equation, okay, and what we have as a solution, we want to use everything that basically overlaps. So in this case, yes, negative 7 or greater is part of our domain. However, our answer calls for something that is greater than or equal to 9. Where our arrows on our number line overlap is where we'll find our solution. And because it's a closed circle, our solution will start bracket 9, comma, infinity. So I know that you've seen inequalities before, and we've used number lines. This is just a little more of a variation to it. It's a little simpler, I feel like, than some of the things that we've done in class before. But the big thing is find out your domain. Then from there, find out your solution. Put both on a number line for your inequalities and see where everything kind of overlaps or intersects. You might even have more than one or two things. Yep.
Where does negative 7 go?
Negative 7 comes before 9, so it would be on the far left.
Or is it like the other 9 and infinity?
Oh, you don't. So you don't, since it doesn't overlap from negative 7 to 9, you would not use that as part of your solution. Your solution is mainly based on what you get when you solve. Your domain is there to tell you what part of restrictions you would have within that solution. Good question. All right, let's take a look at example number 4. Okay. See if you can do this one, and I'll just kind of quietly in the background go through some of it, and you can check your work. Yeah. Oh my gosh, I forgot to square the 5. Thank you. Hold on a second. We'll get a number that's greater than just 4. There we go. 14. That works a little bit better. So if you notice how they're both going different directions, with domain, it's always setting it greater than or equal to 0. And then from here, it's whatever the solution kind of tells us or dictates. And then it's the overlapping region. Because at 3 halves, there is a closed circle. So it would be 3 halves, comma, 14 parenthesis for our solution. Okay. I apologize for that. I just lost in thought. All right. Take a look at example number 5. I'm going to kind of walk you through this a little bit. This is going to be one of our no solution type of situations. So if I want to, I want to get the square root by itself. So in this case, I'll have the square root of 2x plus 1 is less than negative 3. A radical, in order to work, has to be somewhat positive on the inside, and you'll end up with a positive solution. That positive number will never be less than a negative. So in this case, this will be no solution. Questions at all? No? Yeah.
Sign was flipped.
If the sign was flipped, there is a possibility that it could work. You'd also have to then solve it out and do your domain and then look for it. But yeah. So if this is set, for instance, greater than a negative number, there is a possibility that it could work. If you're unsure, you can still go through these types of problems and solve them. You'll see on your number line where things won't necessarily line up or overlap. And in that case, if you don't have an overlapping region, then there's no solution as well. All right, and then example number 6. Example number 6 has 2 different radicals. So each of those individually, we're going to want to set greater than or equal to 0 to find out what our domain's going to be. So let's go ahead and do that first. So 9x plus 7 is greater than or equal to 0. 9x is greater than or equal to negative 7. X is greater than or equal to negative 7/9. And 14x is greater than or equal to 0. So x is greater than or equal to 0. We'll put those down on our number line here in a minute. Let's first find out what our solution is to our equation. They both are square roots on each side. So I'm going to square both of them. I don't have anything not underneath a radical. So this will give me 9x plus 7 is less than 14x. I usually like to keep my x on the left side. That's just my preference. So if I subtract 14x here, I get negative 5x. And then if I subtract 7, less than negative 7. And then I'm going to divide by negative. When I divide by negative, that flips my sign. So I end up with 7/5. Now all three of these will go on the number line. Start with 0, since it's kind of like the centerpiece for everything. And that's going to go forever that way. I've got negative 7/9. And then I have 7/5. Again, even though there's three things, that just means that all three have to be overlapping in order for us to count it as our solution. So as you can see at that very back part here that I'm about to highlight, the 7/5 to infinity. So that's what we're going to go with. So bracket, or you know what? Yeah, it is going to be a bracket. I apologize. Hold on one second. I did make one small error. This circle is going to be an open circle. Okay. However, because these other two are going through as well, we're going to say 7/5, comma, infinity. Questions at all? I think that was that the last example?